Alright, this is your lesson for 10-1, the Pythagorean theorem and its converse. On the screen I have two theorems. The first one is just the Pythagorean theorem. It's if a triangle is a right triangle, then a squared plus b squared equals c squared. Most of you learned this back in middle school, so that's just a review. But the second theorem is new. The second theorem is called the converse of the Pythagorean theorem, and what that says is that if a squared plus b squared equals c squared, then the triangle is a right triangle. So in this case, you don't know that the triangle is a right triangle yet. You're trying to see if it is. So I'm going to do an example. So here in the first example, we have a right triangle. They gave us 3 and 4 and x. The x is the hypotenuse, which means that that is c. A and b don't matter which one you call, just as long as you call the legs a and b. So in this case, we have 3 squared plus 4 squared equals c squared. 3 squared is 9, 4 squared is 16, so that becomes 25. And then you square root both sides, so c equals 5. For this one down here, same thing, except this time we don't know a, but we know b and c. So we have y squared plus 4 squared equals 15 squared. Y squared is equal to 225 minus 16, which is 209. Sorry about that, 209. Then we square root both sides, and you get the square root of 209. Here's where you do the prime factorization tree, and I'm going to go ahead and pause and do that real quick. The square root of 209 does not reduce to anything, so this would be your answer. Alright, on this slide what I have for you is the Pythagorean triples. Basically what a Pythagorean triple is 3 numbers that satisfy the equation a squared plus b squared equals c squared. On here you see 4 different ones. These are not the only ones, there's a ton of them. But if you start out with those and multiply all of them by the same number, then you'll get a new set of Pythagorean triples that'll work. Pythagorean triples are basically numbers that you can use to kind of answer the problem faster. This would be good for, say, the SAT or the ACT, or if you're going into maybe the military, it'd be good for the ASVAB when you're taking that test. In this case, if I tell you that the 2 of the sides of the triangle are 3 and 4, and I told you that you're trying to find the hypotenuse, well then you can automatically say that the answer is 5, because those numbers will always work. Again, this is the formula that they satisfy. So if you're given 3 numbers and they want to know if they or if they're a Pythagorean triple, you can use that formula to see if they are. Okay, the last 2 theorems that I have here is the theorem 10-3. If c squared is greater than a squared plus b squared, then the triangle is obtuse. So if you take the 2 legs and square them and add them, if they are smaller than the hypotenuse squared, then it's just an obtuse triangle. Now in this case it wouldn't be a hypotenuse, it would just be the longest leg. Remember that c is always the longest side of whatever the triangle that you're given. The last one is that the c squared is less than a squared plus b squared. If that's the case, then it's an acute triangle. So basically, if you take the square of the 2 smaller sides and you add them together and they're bigger than the squared of the bigger side, then it is an acute triangle. So here's an example. A triangle has side lengths 6, 11, and 14. Classify this triangle. So in this case, we see here that the biggest value is 14. So 14 is our C. So we need to see if 14 squared is bigger, less than, or equal to 6 squared plus 11 squared. Well, 14 squared is 196, 6 squared is 36, and 11 squared is 121. So if we add those numbers together, this is 157, this is 196. 196 is bigger, so this is an obtuse triangle. Okay, so those are the formulas that you need to know. Those are the theorems that you need to make sure you're familiar with. Tomorrow in class we will have an assignment over this, so if you have any questions you can come see me before class or you can ask me during class. Have a good afternoon and I'll see you soon.